In this video, we're going to look at some AP style questions that have to do with limits. In this first question, we're given a graph, f of x, and three statements, and we're asked to identify which of the statements are true. Our first statement says that f of -1 does not exist. So if I look at my graph here at x is equal to -1, I can see here that I have a closed-in circle. My function has a value at -1, and that value happens to be 1. And so the value of f of -1 does exist, and that makes that first statement false. The second statement says the limit as x approaches -1 of f of x is equal to 1/2. So if I go back to my graph and look at -1 as x approaches -1 from the left and the right, my function is approaching this value here on both sides, and that value happens to be located at 0.5. And since both sides of the graph are coming together at the same place, even though there's a hole there, the limit still exists, and the limit is equal to 0.5. And so my second statement here is true. Now the last statement says that the limit as x approaches -1 of f of x is equal to the value of the function at -1. Well, if I go back to my graph, remember my limit was equal to 0.5. This value is 0.5 or 1/2. But the value of the function at -1, that's this point up here, which is located at 1. And so those two things are not equal, and this statement is false. And so our correct answer here is that 2 is the only statement that is true. Okay, let's look at our next question. We've still got the same graph showing here, but a different question. On this one, we're asked to evaluate the limit of f of x as x approaches 1. So if I look at my graph, as x approaches 1 from the left, my graph is approaching this value up here at 0.5. But as I approach 1 from the right, my graph is approaching this value down here, which is a 0. And since my left-hand limit and my right-hand limit are not going to the same value, this limit does not exist. And so our answer is answer A. Question number 3, it's asking us to find the average rate of change of a function f of x equal to x squared minus 3x on the interval starting at 2 and ending at x. And it tells us that this average rate of change is equal to 3 and asks us to solve for x. So this is where our flashcards come in handy, because you have a flashcard for average rate of change. And it says that the formula we should be using is f of b minus f of a over b minus a. So I'm going to write out here on the side, f of b is, in this case, it's just going to be f of x. And so in the place of f of b, I'm going to put f of x, which is x squared minus 3x. Then I need to subtract f of a. Now my a value is 2, and so I'm going to plug 2 into my function. F of 2 would be 2 squared minus 3 times 2. And this is all over b minus a, or x minus 2. So that's my average rate of change using the formula. And they told us in the problem that this should be equal to 3. So I'm going to set it equal to 3, and then let's do some algebra and solve this equation. I've got x squared minus 3x. If I distribute, well, actually, let's calculate what's inside these parentheses here. 2 squared is 4 minus 6. There in the parentheses, I get -2. And so if I have minus -2, that actually becomes plus 2 over x minus 2. This equals 3. So now I'm going to take my denominator, x minus 2, and multiply it over to the other side. So I have x squared minus 3x plus 2, which is going to be equal to 3 times x minus 2. So now I'm going to distribute my 3. X squared minus 3x plus 2 equals 3x minus 6. And since I've got a quadratic here, the way that I'm going to solve is by factoring, which means I need a 0 on one side. So I'm going to subtract the 3x, and I end up with negative 6x, and then if I add the 6, I get plus 8, and this equals 0. Now, I haven't planned my space very well here, so let me, I'm going to erase some of the work up here at the top. And I've got x squared minus 6x plus 8 equals 0. So I'm going to factor this. And we get x and x. Numbers that multiply to give me 8 are 4 and 2. I'm sorry, that was my dog. And both of these signs need to be negative. And so x is equal to 4 or 2. And since 4 is the only choice that is there, 2 is not among our answer choices, we're going to choose answer C, which is 4. Now additionally, my x value cannot be equal to 2 in this scenario because remember our interval starts at 2 and stops at x. And so if x was equal to 2, then I would have no movement on the interval and therefore no average rate of change. All right, on the next question. Here we're given a piece of information that the limit of f of x as x approaches a equals capital A. And they're saying if you know that is true, they're asking which of the following statements here are true. So let's look at all these statements. Answer A says that the limit of f of x as x approaches a from the right is equal to the limit of f of x as x approaches a from the left. Now, if you remember how we defined a limit in class, we said that if a limit exists, then the limit from the left and the limit from the right, they must be equal to each other. And so this is a true statement. And so technically, if we were confident in our answer, we could stop here. But let's look at the other answers anyway. Question B says that the value of the function at little a is equal to capital A. That does not have to be true. Just because a limit exists doesn't mean that the value of the function also exists and equals the same value of the limit. Remember that when we have a limit, there could be a hole there at that point in the function. Answer C says f is continuous at a. Again, that does not have to be true. If f was continuous at a, then answer B would have to be true. And since we've already said that answer B is false, answer C has to be false as well. Answer D says that the limit as x approaches a from the right of f of x is not necessarily equal to a. Well, that has to be false because if a limit exists, the limit from the left and the limit from the right both have to be equal to the same value, and in this case, that value is capital A. And then question E says that f of x is equal to a, that the whole function is just always equal to a, and that is also false. And so the only answer statement here that is true is answer A. Our final question for this video asks us to evaluate a limit as x approaches 2. Now again, our note cards come in handy here. If you remember, whenever we have a limit of x approaching a number, the first thing we should always try to do is to plug in the number. So I'm going to do that here. I'm going to plug in 2 wherever we have x's over sine of pi times 2 plus cosine of 2 times pi times 2. All right, so in my numerator, I get the square root of, 2 squared is 4, and 3 times 4 is 12, minus 2 plus 6, over, I'm going to rewrite these numbers here in the denominator, sine of 2 pi plus the cosine of 4 pi. And then my numerator, 12 minus 2 would be 10, plus 6 would be 16. So I've got the square root of 16. In the denominator, so now I'm going to think about my unit circle. Sine of 2 pi, well 2 pi, that's an angle on the x-axis. Sine, of course, is the y-coordinate, so that would be 0. And then cosine of 4 pi is coterminal with 2 pi, which is on the x-axis, and cosine there at 2 pi is equal to 1. And so 0 plus 1 is 1. And the square root of 16 is 4 over 1, and it looks like we have a limit, and it is 4.